Perfect. So the topic for the next approximately 25-30 minutes is surfing on an interactive kiosk. My name is Anavi. I'm a senior software engineer at Konsuku Group. This is a service company specialized in embedded Linux and open source software development. My colleagues and I have experience in hardware, software, build, design, development, and training services. And we are contributing to various upstream open source projects, including the Linux kernel, U-boot, Build-root, automotive-grade Linux, and of course the Yocto Project and OpenEmbedded. The company is based in San Jose, California, with engineering presence worldwide. I'm personally working remotely, and I'm based here in Plovdiv, Bulgaria, so I'm speaking from Plovdiv. The agenda of this talk is first to have a look at the web browsers in general. We'll see the stats, which we are almost, I'm sure we're almost familiar with anyway. After that, I'll explain a little bit of two components that are quite old, but does good job, openbox and surf. I'll show how to build an image. Finally, we'll wrap it up with conclusions, and hopefully there will be time for some questions and answers. The purpose of this talk is to demonstrate how to build a kiosk with the Yocto project using rock-solid old technologies and to build it for constrained embedded Linux devices. I'm not going to use any cutting-edge technologies. I'll just show you that, hey, this works and it's simple to do it. Very often people say that the Yocto project and OpenEmbedded are very complicated and hard to get started. With this presentation, I would like to show different approach and to show that something like a kiosk, which nowadays is quite a common task, can be achieved relatively easy and fast with the Yocto project and OpenEmbedded. These are the statistics for the web browser market share as of last month, April 2021. It's a snapshot of the usage of web browsers in the past year. Obviously, as expected, the Chrome browser is the most used web browser with almost 65% of the users using it. The Safari web browser also is quite used. I actually didn't expect to see Safari on the second place, but nowadays it is. The market share of Firefox is going smaller and smaller. And the web browser, which I'll be using in this presentation, is not even part of these statistics. It's a very specific thing, which I'll show you later on in the slides. So if someone wants to build a kiosk or to integrate a web browser and an embedded Linux distribution built with the Yocto project and OpenEmbedded, there is the meta browser layer, which is well maintained. It's quite popular. Actually, I have been using it on several occasions on various different projects. It's available in GitHub under an MIT license. There is a sublayer for Chromium and a sublayer for Firefox. So if you need any of these two most popular web browsers for Linux distributions, go for meta browsers. There you find the recipes, it works, and you can achieve what you need. Sometimes using a browser like Chromium or Firefox brings a lot of features that you don't necessarily need for a specific use case. And if you just need to make a small kiosk, these type of web browsers bring a huge overhead. Also, building a web engine always takes a significant amount of time, no matter what kind of a build system you have. Even if you have a very powerful build machine, still building a web browser with BitBake takes some time because of the dependencies. So instead of using Chromium or Firefox, in this presentation, I'll show you the Surf web browser. Honestly, I wasn't aware about the Surf browser, and 3 years ago, a colleague of mine told me, hey, have a look at Surf. It's a minimalistic web browser. There's no graphic control elements. It's controlled only via keyboard shortcuts or some kind of external tools. It's very simple. It's based on WebKit 2 and JDK, and it's developed by sackless.org. The initial release was in 2009, so it's not a new project. It's a very geeky thing. to use it on a desktop. There are people using the Surf web browser on a desktop, but it's quite convenient for specific use cases, like in the use case that I'm showing now, building a kiosk. Um, Initially, we didn't have a recipe for Surf in Meta OpenEmbedded. So back in 2019, I was working on a hobby project I built a small distribution with Homebridge, and I needed a Surf as a web browser so that I can display local content which is running on the embedded device. It's a simple website for configuration. I decided to go for Surf. There was no recipe, so I had to create one. And initially, after some discussions, whether Meta OpenEmbedded, Meta OE is the right place for such kind of a software, it was accepted. And since then, Surf is available. And by the way, this initial patch and my hobby project was part of a presentation that I did at FOSDEM 2020. This is the last conference that I've attended in person. Now I've decided to use it once again, and I figured out that, hey, actually Surf has a newer version. They've moved to version 2.1. So a couple of weeks, or even less than a couple of weeks ago, I did an upgrade, which is now available in the master branch of Meta OpenEmbedded. And the latest, we have the latest and greatest version of Surf, which is 2.1. Once again, it's a very simple web browser without any controls. It can be just launched in full screen, and that's it. Of course, Surf has some requirements. One of the most important requirement is X11. Yesterday, during the developer discussion, there were some discussions that probably the Yocto project should move on entirely to Waveland, but actually here are some components that are still X11 based. They probably can work on top of X-Waveland. I haven't tried with a web browser, honestly. My setup is with the setup that I'm going to show you in the next slides is with X11 and OpenGL. The dependencies of Surf web browser, WebKit JDK, JDK3, glib2, and GCR. The latter was added recently because of the update of the Surf web browser to version 2.1. WebKit JDK is a full-featured port of the WebKit 2 rendering engine. So in Surf, you basically get what you have in the WebKit 2 rendering web engine. In order to run Surf in full mode, I still needed a stacking window manager. And openbox is a project that does exactly this. It's a highly configurable stacking window manager for the X11 display protocol. It's available under a GPL version 2 license. I have to say that it's not actively maintained. There are no recent commits in the last 5 years in openbox, but it's a stable software that does the job which is supposed to do. It's written in C. XML is used for the configurations. There are several important configuration files that we need to customize in order to get the appearance that we want. And as I said, openbox is highly configurable. That's really convenient. rc.xml is the main configuration file. It's for the overall session, for the whole session. Menu.xml is another configuration file which controls what to show, what should show on the screen when you click the right button of the mouse, all the options there. And through this XML file, you can have a full control of this menu. Finally, there is the auto start file. As the name suggests, this file automatically starts application with openbox. And this is convenient if you are building more rich user experience with openbox. In the case for this presentation, where I'm just making an HTML5 kiosk to render HTML5 pages using the Surf web browser, I'm not using AutoStart because I've written a systemd service. OpenBox is present in Meta OE as well. You can learn more about the project at openbox.org. Here is a screenshot of one simple configuration that I built using the Yocto Project and OpenEmbedded with OpenBox. It has a just a black background and a few applications installed. In the left upper corner, there is this long tray with Network Manager from Managing Networks. I also have Xterm as a terminal application. The web browser is, of course, Surf. I have a file manager and a simple application, graphical user application, a simple application for writing text files with a graphical user interface. So this is just an example that with OpenBox and a bunch of popular applications, you can build a very simple graphical interface for embedded device so that even a user without deep technical background can configure it and manage it. That's why I like OpenBox, and that's why I've often used it for a simple task where I need a very simple graphical user interface based on X11. In order to build this thing, I've used several layers. Actually, it's a very minimal set of layers. Of course, spoke the reference distribution of the Yocto project, Meta OE, Meta Python, and Meta Networking, all from Meta OpenEmbedded. The demonstration that I'm doing here is based on my personal favorite single board computer, Raspberry Pi, and the quite popular BSP layer, Meta Raspberry Pi, which is very well maintained. The examples here are for Raspberry Pi 3 and 4. I've tested it on both of them, and Surface is a good option. Surf and OpenBox are a good option for constrained devices. I haven't tested it on Raspberry Pi Zero, but I believe it will work there as well. Probably a little bit slower, but still work. I've showed you that that the Surf web browser is I showed you that the OpenBox is highly configurable, but in order to make all these configurations, we need our layer where we can create a BBappend file and provide the additional configuration files that we need. Creating a layer is straightforward. Most of the people here have advanced knowledge about the Yocto project and OpenEmbedded. This presentation is more targeted for beginners. That's why I've included the commands how to create a new layer, and after that how to add this new layer to bblayers.conf. I've selected a name MetaMy Kiosk for this layer. It's purely for the demonstration purposes of this presentation. For Surf, I also need a systemd service, which will run after the display manager and wanted by graphical target, which will launch the Surf web browser in full screen and load the URL of the yoctoproject.org. In order to provide the systemd service as part of the Surf recipe in my layer that I've created on the previous step, I need to create a BBappend file for Surf and to install the systemd service. Of course, there's a check to make sure that the distribution is actually using systemd as an int system to make sure we are deploying the systemd service in a compatible environment. Also, I've created a dedicated image for the kiosk. This image is actually straightforward, and it's very, very similar to Core Image X11. So it's a very basic image with X11. I've also added OpenBox and Surf. Obviously, the required distro feature is X11. I've enabled OpenGL, and I've added some additional recipes to provide just convenient tools such as a web, Nano, a text editor, and XWD, because I needed to take a screenshot and to show that this thing actually works. So yeah, this is Core Image Kiosk. Very straightforward, very simple image. The important part here is that it inherits a core image. Once this is done in local.conf, I need to set up the machine. as I told you, I've tested it with Raspberry Pi 3 and 4. Here we have it, the configuration for Raspberry Pi 4. Later on, I'll show you a photo of this working on Raspberry Pi 3. Uh, both versions of Raspberry Pi 3 and 4 are capable of running something like this. I've enabled UART. Again, this is just for my own debugging purposes. I've switched to systemd, and I've kicked off building an image. This is core image kiosk. And another thing that I forgot to mention actually, and it's quite important, is all the things that you see here is executed on top of Meta OpenEmbedded master and even master net. This is my part of the setup that I have for testing my upstream contributions to Meta OpenEmbedded and primarily to Meta Python. So this is something that we are using the master branch, not a stable release, and still everything worked as a charm without any issues. Here is the showcase. On the left is a screenshot taken from a setup which was with, I believe, a Raspberry Pi 4 attached to an HDMI monitor with HDMI cable. There's nothing fancy. As you can see, it's just a web page in a full screen. If you're looking at this without knowing all the technical details that I've already shared with you, you won't notice anything specific. Just a web browser there. If you have a setup without a keyboard, the user cannot make any, does not have any controls of the Surf web browser. So all he can do is just browse the HTML5 content that is shown. On the right is a photo of a Raspberry Pi 3 with the official Raspberry Pi touchscreen display. This is a 7-inch touchscreen display released 5 or 6 years ago by the Raspberry Pi Foundation. It works out of the box with Meta Raspberry Pi BSP layer, so the same image can run in both configuration with HDMI monitor and this touchscreen display. So the screenshot, the on the right, this is an image taken from this configuration. I did it this morning before the presentation. So this was the showcase. This is what I wanted to show you, and we are near the end of this presentation. So I would like to wrap it up with some conclusions before we proceed to the questions and answers. So first of all, I have to say that the Yocto project and OpenEmbedded provide a lot of different options for achieving something like an interactive kiosk Linux distribution for rendering HTML5 content. Nowadays, there are so many HTML5 developers, front-end developers, so it's quite often it's easier to use HTML5 instead of regular desktop application. And I see more and more people interested in having a web browser, people and companies interested in having a web browser integrated in their embedded Linux distributions for something similar as a HTML5 kiosk. Of course, the most popular web browsers such as Chromium and Firefox are supported through Meta browsers. However, through Meta OE layer, we have an alternative, which is the Surf web browser. It's not the right choice for any use case, obviously, but there are use cases where the Surf web browser could be a better option than let's say, Chromium. So keep in mind that building a web browser always takes a huge amount of time. Nowadays, web browsers do so many things. It's not like 20 years ago. Also, I wanted to show you this minimal configuration that has X11, openbox, and Surf. It's a good and easy option for implementing a solution like this for the specific use case. The best thing is that this setup will work on pretty much all the boards out there. Even if you take a very old board with system on chip like Allwinner 820, which is a low-cost Chinese system on a chip, which I believe still does not have Wayland support. You can still run something like this just because it supports X11, and the setup with Surf and OpenBox is okay for all type of constrained, even constrained devices. Of course, this showcase is very, very simple. In order to properly do a distribution out of this thing that's useful in the field, a lot of things will be required. For example, software over-the-air updates. A year ago, I did a presentation about A/B updates with Rauk. I often use Mender as actually Mender is my preferred choice for A/B updates, as it has support for many different boards. Also, continuous integration would be required if anyone is wanting to do a Kiosk for distribution for many devices and maintain it. In long term, at the moment, I'm checking out all these layers manually. There are setup tools such as Google Rep or CAS, Git submodules that can automate this process, of course, with templates for loco.conf and bblayers.conf. And instead of putting all these settings in loco.conf, we can create a distro configuration and move it there. So just to repeat it once again, I think this is a showcase that sometimes for simple tasks, you can use all technologies that are known to work, and you can trust them. Yeah, it's not cutting edge, but you don't necessarily need a cutting edge technology to achieve certain goals. And a combination with X11 OpenBox and some other applications, including the Surf web browser, could still be a good option for delivering something that just works. Thank you very much for your attention. I think we are on time, and I hope we have like 5 minutes for any questions.